Hello class, welcome to Advanced Engineering Physics or ES12, and today's topic is specific volume and density. Let us first define what is a specific volume. Specific volume of a substance is defined as the volume per unit mass and is given a symbol of V. No? So we have here the specific volume is just equal to the volume over mass. So the specific volume of a system in a gravitational field may vary from point to point. And for example, is the atmosphere. If atmosphere is considered a system, then the specific volume increases as the elevation increases. So therefore, the definition of the specific volume involves the specific volume of a substance at a point in a system. Now let's consider the continuum limit for the specific volume. So consider a small volume as the change in volume as system, and the mass be designated as the change in mass. The specific volume is defined by the relation as the limit of the change in volume over change in mass, as the small volume changes to the smallest volume for which the mass can be considered a continuum. So volumes smaller than this will lead to the recognition that mass is not evenly distributed. So in space, but is concentrated in particles as molecules, atoms, electrons, and so on. So since most of the system that we consider are relatively small and the change in specific volume with elevation is change in specific volume is not significant. Therefore, we can say that one value of specific volume or density for the entire system. No, tungod sa kagamay sa iyahang values, then we don't just consider that one as a part, no, or points as the specific volume and a point on a specific density. Instead, we say a value that defines the entire system. No? Next is we define density. So we have here the mass density. Mass density of a material is defined as the mass per unit volume of the material. So we have here the density designated as the symbol rho. So we have here density is just equal to the mass over volume, or just the reciprocal of the specific volume. No? So next is we have the weight density, or the specific weight of a material is defined as the weight per unit volume of the material. So we have here a specific weight is just equal to the density multiplied by the standard gravity. So we can also denote it as this one. So we can also denote it as the specific weight is just equal to, we know that the density is just equal to mass over volume, and then multiplied by the gravity, standard gravity, G. So we can also use this formula, no, in case maglisod mo og memorize sa inani na formula, so pwede ra gyapon ni nato gamiton. And next is that we define the specific gravity. So the specific gravity or relative density is defined as the ratio of the density of a substance by the density of the standard substance. So the density of the substance na imuhang i-compared with the standard substance. So for solids and liquids, the reference is usually the water, while for gases, the reference is air. So we have this formula. The relative density is just equal to the density of the substance being measured over the density of the reference or the standard density. So we have here some of the most basic references in terms of density. So we have here density of water at 4 degrees Celsius is 1 grams per centimeter cube, or it is also equal to the 1,000 kilograms per meter cube. And in the English system, which is equal to 62.4 pounds per feet cube. We also have here the density of the air as 0 degrees Celsius is 1.28 kilograms per meter cube. And the density of the air at 20 degrees Celsius is 1.204 kilograms per meter cube. So with that, we know the formulas of the specific volume and the specific density. Now let's proceed to the example. And solve the given problem. A 1 meter cube container shown in the figure is filled with 0.12 meter cube of granite, 0.15 meter cube of sand, and 0.2 meter cube of liquid, 25 degrees Celsius water, and the rest of the volume is 0.53 meter cube is air with a density of 1.15 kilograms per meter cube. So find the overall or the average specific volume and density.
So let's start with the given. So we have the volume of the container is equal to 1 meter cube. We also have the volume of the granite as equal to 0.12 meter cube, and the volume of the sand, which is equal to 0.15 meter cube, and the volume of the water at 25 degrees Celsius is equal to 0.2 meter cube, and the volume of the air is equals to 0.53 meter cube, and the density of the air is just equal to 1.15 kilograms per meter cube. And we know that the specific volume is just equal to volume over mass, and that density is just equal to mass over volume. And since what is asked is find the overall or the average specific volume and density, then we get the specific volume as the volume total, or the total volume over the total mass, and the specific density as the total mass over the total volume. So we need to get the total mass, and we know that mass is just equal to the density multiplied by the volume. So we already have the density because that is a constant now. So from the table in the presentation, then we get the mass of the granite is equal to the density of the granite multiplied by its volume. So the density is equal to 2,750 kilogram per meter cube multiplied by the volume of 0.12 meter cube. So we get the total of 330 kilograms. Next, we get the mass of the sand. So the specific density is 1,500 kilogram per meter cube multiplied by its volume of 0.15 meter cube. So we have 225 kilograms. Next is we get the mass of the water equals to 997 kilograms per meter cube multiplied by the volume of 0.2 meter cube is equals to 199.4 kilograms, and we get the mass of the air is equal to 1.15 kilogram per meter cube multiplied by 0.53 meter cube is equals to 0.61 kilogram. So the total mass would be equal to 330 plus 225 plus 199.4 and 0.61, so that would be 755.01 kilogram, or shall we say 755. Then let's proceed to the specific volume. So we get specific volume is just equal to the total volume, and we know that the total volume or the volume of the container is 1 meter cube. So we have 1 meter cube over the total mass of 755.01 kilogram. So we get the specific volume as equal to 1 over 755.01. So that would be 1.3245 times 10 to the negative 3. So that would be 1.3245 times 10 to the negative 3 meter cube per kilogram, or that would be 0.00132 meter cube per kilogram. And next is the specific density is just equal to the total mass over the total volume. So we know that the total mass is 755.01 kilograms over the total volume is 1 meter cube. So we get a total of 755.01 kilogram per meter cube.
So that would be for the lecture on specific volume and density. And next topic is pressure. So see you at the next topic.